Hello. I don't know why I'm having some like light issues. Oh, I know why. Hold on. There we go. That's why. One of the lights was not pointing right. So there we go. Okay. So welcome everybody. Welcome to CS202 Online. So today we are going to be talking about operator overloading. So his destructor, yes. I had some memory leaks when I called it destructor there, I guess. Light leaks, but yeah. Okay. So, oh, by the way, I put this thing back here. I voted. Make sure you go vote. But yes, okay. So, I have already videos on operator overloading. I mean, I'm gonna go over operator overloading today, but I have like a it's like 2 hour long video. It's like a 3 part video, I think, of which it's a 2 part. It's a 3 part video, but like 2 parts are the operator overloading, and the third part is an assignment that you're not doing. So don't worry about that. Those are found on Canvas under week 8. Yeah, video lecture on operator overloading. So I'll show you very fast what that is. Because frankly, when I did these, operator overloading was like fresher in my mind because I was teaching 4 sections of the same thing. So by the 4th time I was doing it on the same day, it was pretty fresh. But these are the videos. So the only issue with these videos is that I was not using the zoom feature I use for lecturing. So you are gonna have to go full screen, full HD to be able to read the code, as you can see there. See, but now what I do is I zoom in. I can't pause it. There we go. But now what I do is basically I zoom in here so that we don't have this issue. But other than that, as long as you have like an HD monitor, you should be okay. But watching on your phone will not work. But anyway, so those are really good. I recommend you watch those as well. But I'll also try to cover most of it this week, but we'll see how that goes. Actually, in the summer, I was sick the day I was going to do operator overloading, so I was sick before, but I just made them watch those video lectures on the day that I was sick, since I had to prepare. So I really wanted to make sure that I at least got videos on that this time around. So anyway, that's a lot for this. So I think the best place to start, and I don't know, this was actually on the midterm because one of the 2 instructors actually thought it before and put it there. So if you got that question, it won't count. But it was friend functions. And so I think actually, I'm going to start with friend functions. Sorry, I want to sneeze. So I'm trying to make it pass. Okay. So yeah, sorry. I'm going to start with friend functions this time around with operator overloading. I normally would not start with this, but since it wasn't a test, it might as well be a good point to bring it up. So, how to start this? I was thinking about this as I was yesterday or something, and I wanted to say, well, functions are not your guys' friends. Functions are not your friends because functions can't access private variables in classes unless there are member functions, right, of the class. Well, friend functions exist, and I'm going to show you what they are today, but ultimately what they are is they allow you to access private variables in classes. So a good example for this is like, if we think about the object-oriented programming concepts of like private versus public and the idea of operations and functions within a class, typically any operations on data, which are functions, can be associated with a specific class. And so we have no problem whatsoever with accessing privates. In fact, that's the whole purpose that we make things private and public, right? And we have the messenger functions. And this system works really great, but there are scenarios, operator overloading being one of them, where it is useful to have the ability to access privates without doing any of the weird stuff that I show you with reinterpret cast and whatnot, but just like normal coding. It is nice to be able to access some private variables. And so when you think about a class as a castle, and then you got your messenger functions to go in and out of the castle, they have the keys to the castle to go in and out, right? Well, think of it like now you have a friend who doesn't belong to your castle. They're not a member of your castle, but they're friends. So because they're friends, you give them keys too, so they can come in and out of the castle. And again, they're like from their own castle, but they can come in. And so we call them friend functions. Okay, so yes, let me show you friend functions. So not all your functions, I guess, are your friends. You know, I thought it better when I was thinking about that last night or 2 days ago, but it didn't come out as well. But oh well. So let's say we have a class, and our class has an int x in it. Okay, and so right now this is private, which is the one case in there where actually I do want to leave it private, so that's good. And I can even make a function foo that prints out x. And then maybe let's assign something to x, okay? And so I can also, of course, make a variable y as public just to have. So here we have some public stuff and some private stuff, okay? So if right now in main I try to say something like AA and then say a.foo, that's going to go ahead and print out the value of 45. However, I cannot do this, right? Because x is private. So I'm going to get an error here when I try to compile this saying that a is private. Okay? So that's good. That is what we expect so far. I hope. I mean, you guys just took the test, so I hope. Otherwise, we take that away, it compiles, and then if we run it, we get the 45 printed. Okay? And so we can't access it like this. Furthermore, if I have a function, a public function, global function, you know, just call it var, and inside this function, I suppose that maybe I pass the var object, okay, of a. And then that object of a, I can yet again call foo from the function. So now I can just go ahead and say var a. So I can call foo, but I still have the same thing where I cannot do this, right? Or I cannot even see out it that way, right? So that does not work either. If we compile this way, oh, I forgot to save, then this is fine. But again, we still can't change x directly because it's private. Could we do some pointer magic? Yeah, sure we could. We could say something like cout dereference the address of a, and go ahead and dereference that as an integer. Dynamic cast int pointer of this, and then go ahead and dereference that and comment this out, and I think that this will work. Cannot dynamic cast type of class A into type target is not pointer or reference class. Okay, screw it. We are going to just go ahead and do reinterpret casting. And there you go. See, that works. Okay, so we can access privates doing hackery, but it's not quite very elegant, we shall say. And we could even change them this way. If I go ahead and you know, basically set this equal to 2 and then run it again, I'll see that I've actually updated the value of x, right? So there are ways of doing this, like in, you know, messy way. However, what I want to do is I want to be able to just do this. And then when I call foo, to actually be able to print out, right? So how do I get around this private? Well, all I gotta do is make some friendship between bar and class A. And so how do I do that? Well, I introduce bar to class A, and I'm like, hey, this is bar. He's trusted. You can let him in. He's not gonna break into your castle and like coup d'etat or something. So just give him access. And he's like, okay, you're my friend now. I guess they don't shake hands at this point. They do the elbow thing because of coronavirus. But anyways, they just go like that, or I don't know, whatever people do nowadays. So yeah, and then basically that happens, and so he gets added to his friend list, right? Think of social media. And so essentially that's what happens. You go ahead and say friend bar. And so now, well, I guess I gotta go write the word void. Bar is a friend of A. And so if we compile this, now it compiles, and furthermore, if we run it, now it runs, and indeed, bar has access to the private variable of y. And bar is not a class function. I know that yes, the friend list is inside of the class, so you can see it here, like that it says friend void bar, but that does not make it a member function. Bar is still a global function. So like, as you can see, I'm not calling it, I'm not saying like a.bar like I would say a.foo. It's a global function by all means, but it has access to privates. And again, how do I know how do I know that class A is a friend? Because I literally have to put the word friend in there. Does it make any difference if friend is used in public or private scope? That's a good point. I think it might, but you know, it's been a while, so let's go ahead and try it by just moving it over there and see if it compiles. So yeah, it compiles. So there you go. So I guess it doesn't make a difference. Or if it does, I don't know what that difference really is. So yeah, that's a good question. I don't know if like the modifier is affecting it. I know that putting the fact that it says friend and then the function name makes it a friend function, but I don't know if private, public, and protected have to do something with that. I guess it makes sense it doesn't, but at the same time, you know, I'm not gonna claim that I know for sure because I've never really bothered to go that deep into it. So yeah. So anyways, that's friend functions for you. So you know, I don't know if there's friend classes, but I would assume there might be, but I've never tried it. I'm just gonna quickly Google friend classes C++, see if that's a thing. Yeah, friend class and friendship. Yeah, so there are friend classes as well. So you can do that by saying something like, apparently, if you have a class B, and then in this class B, you do something like friend A, I think. That's what I just saw. Here, I'll post the link I just looked at. And I'll post it on the description of the YouTube video as well. But yeah, so now class link list can access private members of node. So in that one. Okay, yeah, so that's pretty cool. So I thought I've seen this before, but I don't remember. So in this case, like if you want to see a practical use of this, would be if I have a function here, like void, oof. I was trying to think of foo bar, but I was like, I used them both already, and I don't want to confuse you guys. So in here, I can say something like, it takes an object of A, and then it does the same thing. A.x gets 20, and A.foo gets called. So now, if I make a B, and then do B.oof, I think this will work. We'll see. Ooh, we got, okay, well that's just because of this. Okay, x is private in which context? Int x equals 45 within this context. Oh, I made the wrong friend. So in this case, I gotta say that B is a friend of A. Now this might be an issue here because of like the referencing. I'm gonna see if that's. I might have to do like a class prototype to get this to compile. B doesn't name a type. That's what I thought. So I either have to make a class prototype up here that says class A like that, or sorry, class B, or I have to physically move the class B declaration on top of that. Because what's happening is because the compiler looks from top to bottom, it sees friend B and he's like, what the heck is a B? Right? Because he hasn't seen this code yet. So either I have to move this code up here, but if I do that, then this is going to cause a problem with this actually, because then it's going to be like, what the heck's an A? So if I put literally this code up here, like I copy and paste these lines up here, then we're going to have the opposite issue because it's going to be like, what the heck's an A? So I think I will get around this by just putting the prototype like that. So that worked, but be careful because if you mess this up, this whole ordering, you get some circular referencing nastiness. So anyways, no matching function for call to B oof. Why not? Oh, because I forgot to pass the A. There we go. And now void oof A is private. Oh, okay. Well, now I gotta make this function public so I can call it from main. And I think we should be good now. So there we go. All right. So let me explain to you what happened here. So I created an object of B, and then I call the function oof in B. If we look at function oof in B, it takes as a parameter an object of A. So I pass in the A. Okay. So I change X directly to 20, and then I call the A foo, which just prints out 20. So we'll print out what's in X, which in this case is 20. So as you can see, I am accessing the private variable X in B. And how do I do that? Because in class A, class B is a friend of A. As you can see here, friend B. This is friends list per se. And so again, that basically says that he has access to the variables, okay? So this can be useful, I suppose, when you have some really nasty code that's very complicated. Frankly, that's why I don't really use friends a lot, because friends is like patching code that's kind of iffy. I mean, there are scenarios where friends are like actually useful, but which is operator overloading being one of them. But you know, they can be used for other stuff. So as you can see, again, it didn't matter if I made it public or private. I wonder if it's possible to make a parent class have a friend function in a child class. Ooh, like if B has to privately inherit from A somehow, but if you want bar to B to have friend access. See, so you know, I'm not sure. I have to like think about that. But the main issue that I see happening is this. When you have a class that references another class, right? So if you have a class A references class B, so we got A on the top and B on the bottom, okay? So when the compiler is running this, it needs to be able to know what is here, like all the code. So if B pops up here and it hasn't seen it yet, you're gonna get errors. So then you're like, okay, I flip him around. So then you get the opposite, you know? If A pops up here, because this is B now, and then, you know, before it hasn't seen it, you get errors too. So then you do what I did with the prototypes, right? But that's not a full solution. Like, there are scenarios, like the only reason that works here is because like class A is only, it says that friend B is you know, B is a friend of A, and it just says that. So it doesn't really have any details about that. But like, suppose that I had a function in class A that was like dealing with B. So like, let's say B had like a variable X or variable Z. And then I was messing with that variable there, even if it was public, that doesn't matter. The fact that I am calling functions or variables from the class, that it means that it's not enough to just put the class prototype there to be okay. So then you get what I was talking about with circular referencing, where like the code cannot compile because it's like pointing to each other and it has to look at one code fully first. So like it just flat out does not work. So this is something that you're going to inevitably run into. And it can be fixed by basically not doing it, which is harder to say than it is, because sometimes when you want to be able to have these references going, and some languages let you do that, but C++ is very strict about that. So yeah, but do remember that. I mean, I'm trying to think if like if what you're saying could work. It could kind of work, but it's just nasty. Like, I know what you're saying. You have a parent class, and then you inherit privately, or you just make them private and the parent, and then you use a friend to access them. It could in theory work, but it just sounds really nasty, you know. I mean, we can very quickly try it out. Just to make sure that we're on the same page. That's that. And then you make a class B, inherit from A, again privately. And then in this case, oh, and I suppose you gotta make a class prototype. And then friend B. Yeah, I don't know. I don't think that, I mean, it might compile, but there's not a lot of uses you could have with it, because again, if you start messing with B on A, it's gonna run into the circular referencing issues. Void foo and cout X. And let's set X to something here. B dot foo. All right. And then this is up to. Class does not name a type. Oh, well, I made it uppercase, that's why. And then semicolon. So I'm able to access it. So as you can see, you can do it, but I don't know if you're really gonna benefit from it much, because again, what I'm trying to mostly say is that suppose that I had a function here that was dealing with an object of B, you know, and then I did something with an object of B which had the Z in it. That's when this is gonna run into problems, like, you know, because of the circular referencing. Like, it doesn't know that, even though you put a prototype, it's not enough to tell it like what the members are. So like it starts to run into issues. So it has incomplete type. That's the error you typically get with circular referencing. I was thinking like friend be foo, not make B a friend class entirely, but give one function in B friend access. Can you do that? Can you make a specific function? I don't know. Maybe. I've never tried that. That would make this code look like this. And then let me get rid of this for now. So it compiles. I see. So we get the circular referencing issue because it's inside of the class. So it can't, unless we can put this class, which you can because it's inherited. So I don't think there's a way. I also hear your qualms about how it probably won't be useful. I just wonder if it's possible. Also, stream delay is long today. You can try refreshing. But yeah, so the issue I see with this is that because this function is inside of the class, you need to be able to, and that function could potentially call any class variables, you know, such as like, I could put in here like cout z, even though I didn't, which already gave me an error, but like if I put it in there like that. So the problem is, to be able to know what this function does and how it works, this full code needs to run. And for this full code to run, it needs to know A. So A has to definitely go before B. And so putting this prototype is not enough to get this going. And putting this on top is going to break the code. So essentially, you're kind of in a bad situation where I don't think that this would work because of circular referencing. So yeah, but I mean, it's good. It's good to think about. But I just I don't really see how we could get this going. Be a mess. I mean, if I move this up here and then switch this to say A instead of B, I don't know if that's gonna compile. Yeah, so now we got the opposite with A. So yeah. So anyways, that was fun, but we'll move on now. We're gonna kind of get rid of that. Delete the evidence of that. But it's good to think about. So anyways, missed phone calls. Okay. Now we're going to go ahead and talk about operator overloading, since that's a topic, right? And so why are friend functions going to be useful for operator overloading? Why did I talk about friend functions? Well, friend functions are cool. And why did I wait until talking about operator overloading to talk about friend functions? The reason being, because let's think about what operator overloading is. Like, it might be just fancy term now, but I want to simplify what I'm talking about. If I got two variables, you know, x and y, I can do x plus y, right? There's a set of operators that are built into C++. It's a fixed amount. You can't make new ones. You can't delete old ones. You can't change order of precedence. In fact, let's talk about what you can and can't do in a minute. But because I actually have a list of things that are very useful to go over. But the idea being that with the built-in operators like plus, minus, multiplication, division, some of the weirder ones like dereferencing, or what other operators do we have? Post-increment, pre-increment, logical operators like and or not, bitwise and or not. Well, bitwise and or. No, there's no not bitwise. What else? What other operators do we have? Think about, put them in the chat if you think of any of them. But there is, well, there's like the member access operator, you know, that's technically an operator as well. Arrow operator. I already said the address of operator. But anyway, there's a bunch of them. And you can probably think of more. And there's probably something we never even talked about that I might not be thinking about right now. But anyways, the point is that all of these operators only work with built-in data types, with one exception, because technically strings are not built in C++, even though we kind of just assume it to be the case, you know. But technically, if you have two strings, they actually, you know, some operators work with strings, like the plus sign. So this, of course, is not addition. It is known as concatenation, which means just like stick both strings together and call it a day, right? So we have these operators that work in designed ways, and you know, that's kind of the end of that. That's just how they work, right? But here's the thing. If we have two classes, or we have some custom objects, which again, probably classes, or I mean, I guess it could be a struct too. But if we have these two, you know, actually just one class. Let's say just we have one class, and we have an index in it, and we're gonna make that public, okay? So if we try to add two of these objects together, then is that gonna work? No, it will not work. Why? Because the compiler doesn't know how to add them. Like, what does adding mean for these objects? Now, you might be thinking in this very basic example that adding two objects of A should be just adding the x's in them, right? So like, if we have an object of A where x has a 5, and another one with A has a, you know, an x of 6, and we add them together, then we get an 11, right? Well, the compiler is not that it's not smart enough, but it doesn't want to make that assumption, because at the end of the day, it's an assumption, and that might be the wrong assumption to make, which is even worse than, you know, not doing it. Because if there's anything worse than code not working, is code that looks to be working, but it's actually wrong, because that's a lot harder to fix, right? If we could catch all our errors at compile time, that would be like super nice, versus like catching them when we've released a product to the public and then like the computer lights on fire or something and customers are angry. So yeah. So anyways, that is why operator overloading is only working for built-in data types. Current operators. But now with operator overloading, we're going to extend the operator's usage to new data types, such as classes objects that we make. So now we can define exactly, so there's no assumptions, what it means to add two objects of A. If we want to, if that represents to us adding the x that are contained in between, then sure, we can do that. If we had two variables in here, we had an x and a y, and it meant adding two x's together and two y's together, we can do that. The point is that we are able to have control over how we want to do that, and we have to explain that to the compiler so that it will actually compile the code. Otherwise, you can't do it. So let us go ahead and do that then. Let me go ahead and make a constructor here, just really quickly, so that I can speed up the code here. We're gonna put int x and int y, and we're gonna give them default parameters of 0 each, and then initialize the variables like that. Okay. So yeah, that's good to go. All right, so now we're gonna go ahead and make two objects. I don't want to leave this as an example, so I'll just put that there like that. We're gonna make two objects. We're gonna call them A1 and A2. Okay. If we do them like that, of course, we're gonna get zeros. So here, we'll do one like that, and then the other one we will manually throw in maybe actually both. So I don't like zeros. So we can do something like 3, 4, and this one we can do like 1, 2. Okay. In fact, yeah, we'll do that. So of course, right now, if we try to say cout A1 plus A2, it's a, I don't know why I'm thinking of this term, double whammy. I probably saw that in a movie or something. But it's a double mistake, right? Because first of all, we have an issue. How do we add the A's together? And two, cout is the same as operators. It does not work with built-in data types. I'm sure, because I'm sure I did it at some point. You know, when you take that introductory course to programming, and then you learn about arrays, and you're like, let me print out my array. cout, and then you put the array name, and then it's like, no. Or it prints out garbage or something. And then you're like, oh, you can't do that because arrays, you know, you have to manually print out every element, right? But wouldn't it be cool if you could do that? I think it would be cool, which is why there's Python, which you can do that and not have to worry about all this mess. But anyways, in C++, you can't do that. So, but you can overload and get it to work that way, actually. And so similarly here, you can't see out just an object, because it's like, what does that mean? Am I supposed to see out the x and the y, only the x, only the y, what ordering? Like, are they integers? What is it, right? Well, that is another thing we're going to do with operator overloading. We're going to tell cout and cin2 potentially how to print out these custom data types. So see, operator overloading is what some people like to refer to as syntax sugaring. I think syntactic sugar, I think is the term, which means it's not something that is strictly required in your programs. You're not going to achieve additional functionality this way, but it will make your code look much nicer. And it will also help you when you're working with polymorphism and templates. So that is one good usage of that. I would say that's the only usage of it where I would say that it's actually like very useful. Everything else, it's just trying to make your code look prettier, basically, which may be at the cost of readability sometimes, and writability and reliability. So yeah, okay. So this is the goal. We want to achieve this code to compile, and that is today's goal. If we do that today, I will be happy. Right now, of course, we get that big nasty error, which hopefully you all at this point have associated with cout. Whenever you see like a big nasty error with the little note thing and everything, blah, 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 of course you should just scroll up all the way to the top and see where that's coming from, which is of course operator plus in this case. So actually that is part of the error from operator plus, and then somewhere else must be the cout operator part. But yeah, as you can see, it says no match for operator plus. That actually is a very good error because it's telling us what's happening. It says that the computer doesn't know how to add, how to use a plus between two operands of type A and A, which is true. The left hand and the right hand in the example that I wrote are objects of class A. So it's like you have a plus and you got these A classes. Like, what do I do with that? And I'm like, don't worry, I'm about to tell you what to do with that. Okay? So there are two ways to overload operators. One of them is, of course, the friend function way, and then the other way is to make a member function. So I'm going to show you both. Let's start with the member function, and then let's do the friend function. Actually, yeah, or should we do the? I'm trying to think which one we should do first. What about you guys? Which one do you guys want to do first? Do you want to do the friend function one or the member one first? Tell me. Meantime, I'm going to see here. I'm looking for that one list of things of what you can and can't overload, because it's a really nice list. I have it on Canvas too. So chat, which would you like to see first? If you guys are alive. Friend. Okay, cool. We're doing friend then. All right. So with friend one, I'm trying to remember how to do this. So we'll try our best. So what we want to do is let's write the function first, and then let's make it a friend afterwards, right? Because and that's actually the reason why I decided to put one public variable and one private variable. You don't know the friend one. That's okay. So the reason why I made one public and one private in the class is so that I can show you. Because technically speaking, if every variable is public in the class, we don't even need to make it a friend function. We can just make it a normal function. So let's start out by saying that the addition of x and the addition of two A objects is strictly adding the x's in it, which are public. Coincidence, I think, whatever. All right. So first of all, this is where you gotta think about how the operators work. In C++, most of the operators don't just do operations in between, but they also return something, right? They return the result. If you're adding two things together, you need to get the result back. It's useless to add them and then poof that answer out of existence. We want to be able to get that answer back and store it in the variable, right? That's very, very important that we do that. And so we need to put a return type to this. So what is the return type that we need? Well, this is again where it's up to you. If in your world, adding two objects of A returns an integer with the resulting addition, that's okay, you can do that. Or maybe it returns a brand new object of A with the added result. So we're gonna start easy. We're gonna start out by saying it returns an integer just so that we can print this out. Otherwise we have to overload the cout as well. So we'll start with that and then we'll swap it, okay? So it returns an integer. And so what function is going to be used here? What is the name of the function for operators? Well, the name of the function for operators This is where I hopefully remember everything. You write the word operator, and then you write the symbol that you're trying to overload. So the plus, minus, multiplication, division, and so on. Once you do that, you go ahead and you put in parameters. What your parameters are the operands. So in this case, it's a binary operation, right? Because there's left and right operand. So in this case, what are the operands? Well, they happen to be objects of A, right? We're going to call it like left and right hand. Now, I think you don't want to pass them. You want to pass them by reference to avoid weird things from happening. Is that where you put the ampersand? It just like left my mind for a second. I think no, it's after. Like that. Okay, and then you don't have to do this part, but I'm gonna do it anyways. Make a const, which is so that you don't accidentally change, because like when you add two numbers together, you don't touch the original numbers, right? Like normally. I mean, again, you have the power to do these things. You have the power to change these things if you want. But by default, you know, if I say 2 plus 4, I get 6 back, and then the 2 and the 4 are like intact. They don't just become all of a sudden like -1s, right? But hey, you can. In your world, which is your program, you can do that. Reality can be whatever you want it to be in this. Okay, so that's the parameters, that's the return type. All that remains is writing the code. So in this case, we are going to say return and then left x plus right x. This works because these are two integers, and we know how to do that. But whatever it is that you need to do for your mathematical computation, you would do it here. Again, right now we're just returning an integer, but I'm going to upgrade this in a minute here to return an object. But that's baby steps, you know. So I think that's it. I think we're good. Let me try it. It compiled. 4. So is that good? Left and right. 3 plus 1 is 4. Okay, yeah, 3 plus 1 is 4. I was like, for a second, I remember big numbers, and I was like, that does not look right. But yes, 3 plus 1 is indeed 4. So we have indeed achieved 3 plus 1. Okay, so it works. I have added two objects of A, and I got an integer back. But that's not very fun. It actually logically would make more sense that we actually return, as I said, an object that is like the resulting addition of them, right? So let's go ahead and update that. But because then the cout will not work yet, we're going to comment this out for a minute, and we're just going to say we're going to call it answer, A for answer. And then we're going to say A1 plus A2, and then we're going to cout the answer's X. That way we can see what's in there. You need to do the class declaration? Nope, I don't so far because it's a public variable. If I try to do the Y, that's when I gotta do the friend part. I'll get there in a second. All right, so there we go. We still get the 4, right? But we still get the 4. Why are we still getting the 4? I never changed that. Ooh, this is like some nasty stuff that I'm doing here. I'm assigning 4 here somehow. Oh, maybe I just didn't compile. No, I did. Okay, I'm not sure why I'm still getting the 4 there, because I actually am still returning an integer, and yet I am putting that integer into answer, and somehow I guess that's because. Okay, so like this is like some like weird thing that's happening here. I know exactly now what's happening. Might as well tell you since I did it. This addition is still working. This is getting an integer back 4, right? And then it's storing it into like overriding A. But what is A? A has an integer on the first spot, right? This is where you got to think about like pointer arithmetic. So it's actually, you know, it's just sheer luck per se that we're actually overriding this X, and that's why this is actually working right now as is. So yeah, this is like some nasty code that just, it's wrong, but it just happened to work, okay? But it's wrong, okay? But understand why we still got the A, because even though this is an integer and this is an object of A, and like it really shouldn't be, but we are basically taking an integer and putting it in an object, It also happens to be the this pointer, which is pointing to the first variable of the class, which is the x, which is why we actually get lucky and do that. But yeah, in fact, this probably could be a way to override a private too. But yeah, okay. So anyways, ignoring that ever happened, let us just make that an A. And so now, let's make a temporary object here. Again, we'll call it the answer. And then we're going to basically assign the answer x to be equal to the left plus the right. And then once we do that, we go ahead and we return it. Okay? So we're going to get 4, but I guess we're doing it the right way this time. Oh, stray slash. Oh, yeah, indeed a stray slash. That's actually a very nice compiler error. It actually told us what was wrong. So as you can see, the right way we got 4. The previous way was wrong, okay? We just happened to be lucky there. I mean, unless we're like on the next word level that we just decided to do that because we knew it was right and it would save us writing code. But this is the right way to do that in this case, okay? All right, so now we are able to add 2 objects and not return an integer, but return an object, okay? But okay, as somebody was saying, you know, why if we don't need to do anything on the class declaration, then why you tell us about friend functions? Well, because the moment that I throw in here a private variable, like that, so now I'm adding not just the x, but also the y. Bam! I get all these warnings about accessing private variables, right? So now the addition operation, or the addition function in this case, it's like, yo, you're telling me to do this addition, but I don't have access. Like, can you let me in, please? And then class A is like, sure, you can be my friend, come in and look at my variables, I suppose. That sounds weird. Okay, so yeah, that's basically what we're gonna do. We're going to, I'm gonna put it at the bottom since we kind of established that it didn't make a difference on where it was. We are going to add him to the friend list and say friend of a operator. Basically this, I'm just gonna copy paste it. Like that. And it doesn't need the actual variable names, just the variable types. Because technically speaking, remember, we can overload functions, right? We can have a function called foo that has 1 integer as a parameter and then another one has like a float. You can make one of them a friend, but the other one not, by the way. So yeah, so we want to make sure that we make the right one a friend. Otherwise it's like, you know, on Steam, when somebody asks you with the same name as your friend, pretends to be them to steal money, you know. I've never had that happen to me, but I've heard so many people where it has. So beware, be safe on the internet. Okay, that. Cool. So now we'll still get a 4, but we actually added the y's. So if we were to see out both the x and the y, shoot, that's not gonna work because of the privates. But hey, we can either write a function that prints out y here, or we can do our pointer magic. So let's do pointer magic. So this is right now a value. We're gonna get its address, and we're gonna add 1 to that, and then we're gonna dereference that address. All because I don't feel like writing a simple getter function. Either way, it's just temporary. There we go. We can see the 6 now. See? Private variables are nothing to us now. Look at us. We just like accessing privates like nothing. Who cares about privacy these days, right? So again, privates are not supposed to be safe. They're supposed to be like an honest man's thing. So you don't make, they're meant to avoid problems. They're not meant to be like a secure thing. You know, think about that a month ago when I said the opposite, but such is life. So anyways, as you can see, we can access both the 4 and the 6, which is the result of adding 4 plus 2. So cool. All right, but anyways, this is nasty. And again, remember, the end goal is this line of code. And if we were to try to do this line of code right now, it's going to give us that big nasty error. See? Bam, big nasty error. Cannot bind, blah, blah, blah. Okay, so that's the last step. Now we got to overload this guy. So before I do that though, let me make sure that I go over what I just did here. So I created a function called operator plus. This is a very special function. I'm technically not creating the function. I'm overloading it because it already exists for all the built-in data types. I'm just adding one more overload of it. So I'm overloading the operator, hence the topic of the title of today, operator overloading, right? So yeah, essentially, once I know that that is what's happening, I go ahead and I write the code of what my addition represents for these specific parameters. So, which is in this case, 2 objects of A. And I'm saying, well, I'm basically just adding all the integers together, like all the x's together and all the y's together, right? However, while the x's work okay because they're public, the y's do not work okay because they're private. So how do I solve that? Friend functions come to the rescue. Friend functions. I go ahead and in class A, I make a kind of like a function prototype of the operator overloading that I did, but I add the word friend in front of it. This associates and says, hey, this specific instance of this function is a friend to you, so let them access private variables. It's okay. We vouch for them. And so by doing that, now this goes ahead and compiles, and you can access public, private, or protected variables in this function, which then allows you to do the addition of them together. So as you can see, the friend part is only necessary because of the privates. As you saw, I was able to do the same thing with the publics without making it a friend because they're public. Okay, so it's only necessary when they're private or protected, I suppose. Okay, so now we're gonna move on to overloading the stream insertion and stream extraction operators. In this case, we're gonna do the cout, which is the, I always get them confused. It's the stream insertion operator, I think. That's the cout is stream insertion. Technically, we're not overloading cout. We're actually overloading this guy, which is why I guess it's called a stream insertion. So I keep saying cout, but that's the proper term. Stream insertion operator. Okay, and then stream extraction would be the one you use for cin. And why we're overloading that and not like cout itself is because the stream insertion overloading that we're gonna do works not just for cout and cin, but if you're using file streams with like a file stream potentially, or any OS stream or Iostream. And the fact that they're called OS stream and Iostream kind of is a hint that it actually turns out that that's the function that we're going to overload, the OS stream function. So I don't have that right here, but I think I can do this one from memory. We'll fiddle with it. So okay, so if I remember, it has to return an OS stream. So OS stream is a return type, and I think like that. No, yes, no, maybe. And then operator, it might be a pointer, I don't know. That, and then the parameters are going to be an OS stream. Okay, so that's where you put the ampersand, that's right. We're gonna call this OS, or just O, whatever. How about fake out? That sounds weird, instead of cout, F out. No, because that says file out. We'll just call it out. Yeah, out. I like that one, out. Because you can think of F out or cout. Yeah. And then that's the left-hand side. Because as you can see, think of it here. If I was to write cout x like that, okay? Think of that as your binary operator, okay? That's the equivalent of doing something like A plus B, right? The operator is this. This is your left operand, and this is your right operand, right? That's how you got to think about it. So over here, this is the left operand, and then this is going to be the right one, okay? So the left one we're saying out, because it's usually the cout F out order, and then the right is going to be, of course, the class object, which in this case is A. So we're just going to call it A. I feel like I'm missing something there, but we'll find out when we try to compile. OS stream operator, OS stream ampersand const. Do we need a const here? No, we do not, because we are probably modifying. Yeah, okay. I think that's actually okay. So then once you do that, it's as easy as just going ahead and writing your out, your stream insertion, and then, well, we got to think about what does it mean to see out an object of A? Like, how do we want that to happen? Well, let's make it pretty. You know, we could just see out like 2 numbers that represent the X and the Y, but let's make it pretty, right? So, you know, high tier user interface or something. We're going to say class A object. That's going to be the first line. And then the next line is going to be, actually, by the way, just because I want to make sure you can use these now. You can use like endline and stuff at this point. Now that we've done this prototype, it'll work. And then we're going to say X, and that is going to contain the A.X. And then endline. I was going to write cout. By the way, this I see tons of people do this. They'll put cout here. That like defeats the purpose because now you've hard-coded this to only work with cout and it won't work with file streams. So make sure you use actually here the name of the parameter that you passed in. Don't very easy to make that mistake like I literally was just about to myself. It's good, you know, it's kind of good to make mistakes sometimes in front of people because you can point them out. Otherwise, when I don't like, I think when I don't make mistakes like this, and then people kind of don't think about that, and then they'll put that, and then if they're using operator overloading with file streams, then they're like, it doesn't work with a file stream, it's couting, and hopefully then they figure it out. So yes, mistakes are good. All right, so okay, this is actually working. We just have to. We have one more thing that we have to do. So again, this here, technically speaking, if we were only couting the X, not the Y, then it'll work just fine. But the Y is private, so we need to make it a friend. So before we make it a friend, let's run it with just the X. So if I compile and run this, that's the implementation fault. That's funny. Don't worry about that part. But as you can see, it actually was able to say class A object and that. The reason why I'm getting segmentation fault is because I forgot to return out. Okay, I think that's why. Ooh, no. Why? Error, return out. Okay, so maybe I do need a 9% somewhere here. Let's try that. Okay, there we go. So I guess you do need 9% there. So I kind of was thinking about that, but I wasn't sure. So I think the reason why is because you're passing a reference to it again. So yeah, it's like finicky that you're doing that. So just remember that. Accept it, I guess. So or me, don't remember it, but then make see the compiling error and then remember it at that point. So yeah, okay. That's why it's kind of nice that your test is online and you have the IDE to test things. So anyways, as you can see, this is working. The couting, if we go ahead and remove these nasty couts now, you can see that it is literally, we're literally able to add 2 objects and get the result. But of course, the last thing we gotta do is the Y's, right? Because if we go ahead and bring this Y back, then we get the private issue, right? So again, we just gotta make it a friend function. Friend, and then let's just copy paste because I don't feel like typing that. Too prone to issues there. And then get rid of that. Get rid of this. We don't have to. Here, for this one, we'll leave it. How about that? I don't think we really have to get rid of them. It's just that I like to get rid of them because otherwise you can confuse people if you have a variable name here and then something else elsewhere and like confuses them. So yep. I just have to make sure that I bring this return beneath that. And so now we have achieved greatness here. We have achieved the goal of the day, which was to be able to add 2 objects of type A and see out the result. Voila. Questions on this? Anybody? So, if I was you, the questions I'd ask would be, what is Iostream? Iostream, if you think about the name of the include that you have up here, the include is called Iostream, right? And what that include does is it allows you to use see in and see out among other things. And so a stream is maybe like a flow stream, like water stream, a flow of data, whether in or out. In this case, it's going out, so it's Iostream because it's like out stream. And Iostream with an I is like in stream, right? And so what we're doing is we're overloading the operator that outputs stuff, the Iostream operator, and that is what's called Iostream. The operator itself is this one. As you can see, this is an ongoing pattern. You write the word operator and then you write the symbol. That's just what the C++ gods decided to grant us with. And so then we got the fact that we have to give this as a parameter because it's the left side, the left operand, and it is an Iostream, again passed by reference. And again, this is the weird finicky thing here that you have to put as well. We'll also pass return by reference, I suppose. And then I'm sorry, so I'm just distracted by that. But yeah, and then on the right side we have our object. Again, the cons here is so that we don't accidentally mess it up. I do think actually it might give you a warning if you don't put it in. Let's try it. Yeah, that's, wait, really? For that? Oh, I see. It's probably because I now it's not matching with the reason why it gave me that error was because then it was technically a different function. So we were friends with the wrong function. We got scammed basically. But if we get rid of them in both, oh shit, I got rid of it in the wrong one. Hold on, in this one. So get rid of that one and then get rid of that one. I think I seem to recall vaguely. Yeah, we get an error with this one. We have to use const. I think with the plus operator we don't. That one is okay. It's just the stream insertion and extraction can be kind of weird. So you have to really like be pedantic about that kind of stuff. Like you gotta put the const and stuff. So one more thing. This operator plus we can achieve both in the class, which I'm going to show you next, and outside the class. The stream insertion operator, though, we cannot achieve inside the class. We can only achieve it outside. So that is the one case where you have to use a friend function. Like it is impossible to do this overloading without a friend function if you have private variables. Well, not impossible, but it would require this kind of nastiness to be able to access that. So basically you have to go around the fact that it's a private variable, okay? If you can do that, which you can, case in point, I'm highlighting how, but doing it the right way is not possible, okay? So yeah. Again, I'm very compelled to just copy and paste this up here to show you that you can, but yeah, why not? Let's do it. Too tempting to not do it. It's just fun, you know, like it's fun doing this whole like accessing privates when you shouldn't kind of thing. I don't know why. I just find it very cool to do. But yeah, so now we don't need it. We don't need to be your friend. We're breaking into your house right now. This is literally the equivalent of me breaking into their house to get this working. Answer when not declaring the scope. Well, it's just called A. That's literally like actually a very good representation. This is like we're no longer friends, but I still want to be able to print that. So I just break into your house while you're sleeping and print it out. So yeah, I'm teaching a cybersecurity course in the spring though, so I'll get to probably have more fun in that class than this one for doing this kind of weird stuff. But anyways. Now you have it there. So you can show off to your friends accessing private variables, right? Show off to the people in the like the beginning of 135 or sorry, in the beginning of 1202 next semester. Okay, so anyways, we got 15 minutes left. Can we achieve this last part? I think we can. Okay, so there is, like I said, another way of doing the operator overloading for some operators. Again, you can't really do that with this one. I'll explain why for a second. So normally when you have a binary operator, you have the left side and the right side, right? So when you're doing it outside of the class like this, the function, then you just basically pass the left and the right as parameters, right? But in the special case where one of the operands, and in this case, not just one of them, the left operand is an object of the class that you're working with. So in this, for example, it's an object of class A, then you can actually make it a member function and not have to worry about making a friend function. Okay? The reason this works here is because this happens to be an object of A, right? So we can do that here. Here we cannot because this is actually an object of the Iostream class. So you'd actually have to go into the source code of the Iostream library and overload it directly there if you wanted it to not make it a friend function for that one. Again, assuming private variables. Okay? So actually, even then, oh, this does bring up a good point actually. So if you're working with different classes, so like let's say that you're adding an object of a class A and then you add an object of a class B, like some class B, then you're also kind of forced to use friend functions there because you got to put the function either in class A, class B, or the global scope. You put it in class A, sure, now you have access to privates in A. But you can't put it in B because it's already in A. So you put it in B. Okay, now you have access to privates in B, but not in A. So in this case, because you need to access two privates in two different classes, then you need friends in that case as well. So that will be another example of where you have to use friends for that. Because like you either go with one or the other, or you're in the middle but then have nothing, and then you can do friends, right? So you have to be friends with somebody in that scenario. So, okay. So let us, just so we don't repeat ourselves, let's go ahead and do maybe subtraction. So let's go ahead and do the subtraction as a member function. Okay, we're gonna have to cut up some of the stuff in the screen. So let me go ahead and maybe move this one beneath main. Just so that, again, I'll upload the code, but I just want to move it out of the way so that we have space so you can see the full thing. Do I need a prototype in this case? Because it's in the friend function. No, I don't. That's cool. Sweet. Okay. And then we'll leave the plus in here, but we'll put this one right here. Okay? Cool, cool. So, actually, we'll just make it inside the class. We'll start with that, and then we can put it outside. We'll make it a public function because the addition is public, so otherwise things will break. So what we're going to do is we are going to just flat out write the function here. So we're going to say A, because again, the subtraction is going to return an object of A. Could return an integer, could return whatever we want, but in this case, we're saying it's going to return an object of A. Operator minus, in this case, because this is a subtraction, and then left and right parameters. However, in this case, because it's a member function, the left is hard-coded to be the class object. So we only need to pass the right. I'm going to put right there so I don't forget. I could have just put A, but otherwise I'll get confused. Okay? So now, oh, pass it by reference. You don't have to, but I mean, in this one's in this one, the Iostream you do, but here you don't have to, but it's better. It's faster too. So in here, what we're going to do for that is we are going to first make a solution variable like that, and then basically the same thing as here. In fact, I'm just going to copy and paste it. That's the starting point. And then I'm going to be careful about this. This is the problem with copying and pasting. If you don't switch these to pluses to minuses, then you're screwed at that point. And I think I've done this before, like lecturing, where I did it and I was like, see guys, like this is why copying and pasting is risky with operator overloading. That's the other thing about operator overloading. Like, it's very easy to make things unreadable. Like, suppose that you're overloading the plus and you decide that you want to subtract in the plus, like for some reason. So now it looks like you're adding things, but in reality you're subtracting things. And so like that is just the, you want to make your code unreadable, that's the way to do it. So yeah, not a good thing, by the way. So yeah. Okay, so anyways, however, in this case, we don't have a left. Well, we don't have a left because the object itself is a left. So there are two ways to do that. You could just do this, because technically speaking, that's the local variables. But I think it's a little bit more self-explanatory or more readable for somebody working on your code to use the this pointer that we talked about the other day. Okay? Just clarifies it a little bit. And so now, well, let's go ahead and add some. Let's add an example in main now. So let us put here Cout A1 minus A2. Oh, by the way, just to show you that we've got this thing working pretty cool. This is that. Big subtraction going on there. -4 and -6. That's kind of cool that we flipped that. Let's see if that's correct. So we started with A1 and A2, which have 3 and 1. So let's look at the x's. 3 and 1. So 3 minus 1 is 2, and then we do minus 3 and minus 3. So that would be 2 minus 3 is -1, minus 3 is -4, so that is indeed correct. We got -4. And then for the y's, we got 4 minus 2, which is 2, minus 4 minus 4, which is minus 8, so -6. So yeah, yep, we got it right. So as you can see, even the chaining works because we overloaded the operator correctly. So that is pretty cool. As you can see, it's very straightforward once you know how to do it one way. The other way is just putting in here. You just got to know that little trick that the left-hand side is now the disk pointer. Another interesting way that we can write this, by the way, is we could write something like this. So let's say we're doing A1 minus A2. You can actually write that same code by saying A1 dot operator minus, and then pass A2 like that. And that should give you the same answer as A1 minus A2, which is 3 minus 1 is 2, and then 4 minus 2 is 2, so 2, 2. Yep. So, in fact, actually, the compiler converts your code of like this format into this as it's compiling. And that's how it knows that it has to call that function. So this is happening internally. Like, you don't see that. You use the operator because it makes things look pretty, but it's all functions and it's all converting it like that. It's just replacing it. So that's the basics of operator overloading. The trick about operator overloading that you just kind of have to learn is every operator has its own peculiarities. So like we'll go over some other ones on Thursday since we have a little bit of time, but I also have to do error handling. So I'll show you some other cases, but pretty much it's the same system. You write the word operator, you put the symbol, you write the left-hand side operand, the right-hand side, do whatever you want to do with them, and then call it a day. You have to, however, be a little bit careful. So this is the part where I should warn you. Here we're doing nothing dynamic, right? There's no new and delete in this code, fortunately. No memory leaks or whatever. However, in fact, hey, let's confirm the claim of no memory leaks, actually. Okay, no memory leaks. So good claim, good claim. Okay, so, you know, here's the thing about this. The moment you start throwing in dynamic stuff, you got to think back about like the whole shallow versus deep copy. You got to make sure, because you're making objects, like, you know, I'm making an answer, and then I'm assigning things, and I'm returning that. So you got to make sure that you're not making memory leaks when you do that, that you're making deep copies. Also, because you're assigning something here, you know, we make an answer and return the answer, so we're assigning the answer. Like here you can see there's assignment going on, right? You can also overload the assignment operator. I think I showed you that very briefly at some point, but if I did, it was just kind of like I just had to do it, but I'm going to do it in detail next time, because you got to be careful again there with deep versus shallow copy. And more importantly, remember that the copy assignment operator and then the assignment operator, if you overload one of these, you got to follow the rule of 3, and you got to mess with the destructor and the constructor. And yeah, like you got, there's more baggage involved with this stuff that you have to handle, so you avoid not just crashes, memory leaks, but also crashes, I suppose. Okay, so that I guess we'll do next time. What I want to talk about for the last 5 minutes, see if I can find it. I was looking for it like throughout the course today, but there's a list in the DS Malik book of things you can and can't do, or should and shouldn't do. It's operator overloading and some limitations of it. It's like in the beginning of the book, or the chapter, I mean. Here we go, some restrictions. So that, okay. let me share my screen. Right there. Okay. So this is D.S. Malik book. It's like stuck in the middle, but you know, it's the book in the syllabus that's recommended. It used to be required, but we switched to recommended. I kind of want to switch it back to being required because I really think this is a nice book. Like in retrospect, it's actually, at least for teaching, it's nice. It's a nice reference, especially for this kind of stuff that I don't remember. But okay, so some restrictions that I kind of want to go briefly over for the last 5 minutes of class that you should know about. Operator overloading is great, but there are limitations. I have mentioned some of them today, but now we're going to kind of close it up by really nailing this down. So first and foremost, you cannot change the precedence of an operator. What that means is that order of operations that we've been talked about for the full semester, you know, especially with like the reason why we use the arrow operator instead of the dot operator, and how when we, you know, if we wanted to use the dot operator with pointers, we have to dereference it, but then we got to put it in parentheses so that we don't like break things. You know, that whole concept behind that is because of order of precedence. Similarly, in basic math, you know, multiplication has higher precedence over addition, right? So when you're overloading operators, if you have something of the form of like A plus B times C, while you can overload the plus and the times for like dealing with specific objects and whatnot, you cannot change the precedence. You can't make the multiplication happen before the addition in that case. The reason why you can't do that in C++ is because the compiler, the way the compiler works, and you'll learn about this when you take compilers at the end of your CS degree, there's a lot of type checking and a lot of different checks that run through different passes that a compiler goes through to make sure that the code is actually okay. And part of that is actually checking the order of precedence before it even looks at what the objects or what the variables contain. And so, because it hasn't even looked at that yet, then it needs to always follow the same standard with order of precedence. And so that's why in C++ you can't do that. I don't know if there's languages that allow you to do that, but that would make the compiling like scary and a little bit harder. So yeah, but anyways, for C++ you can't. So, no hope and dreams of making A plus B times C make the pluses happen for. Sorry. Second thing, associativity. The associativity cannot be changed. That is basically layman's term for like things will go from left to right no matter what. Again, kind of with order of precedence again. But like if we have A plus B plus C, then it will go A plus B first and then B plus C. There's no way you can make B plus C happen before A plus B. That's trivial. It sounds trivial, but I suppose it's something to make sure that you know that you can't mess with that. Okay? So, yeah. Default parameters cannot be used with an overloaded operator. That one's a little bit more peculiar, but like, you know, we typically use like different default things like this here. We can't just do that here. And the reason being because by having a default, then it just, again, I don't want to go down that rabbit hole, but it just makes the compiler like confused. And so it's like, nope, we are not going to have to do extra work for that, the compiler people said. So yeah. You cannot change the number of parameters an operator takes. What this is saying is you can't change like a unary operator into a binary operator. Now, some operators like the asterisk are both unary and binary, right? For binary, it's multiplication. For unary, it's the dereferencing operator. Because of that kind of operator, you know, flexibility that we have, like not flexibility, but like the fact that we use the same symbol for multiple operators. Because of that, we can't change the number of parameters because, again, the compiler would get confused about this. It's like, are you talking about multiplication or dereferencing? Like, which one are you doing? So, like, it would just be like, nope. So, again, it won't let you change the number of operands and operators, which means you can't change the number of parameters in the function because they represent the operands. So, yeah. Again, this is sort of an ongoing pattern, like the compiler. Yep. In fact, the next one is, again, because of the compiler. You cannot create new operators. Only existing operators can be overloaded. What this is saying is you can't just like pick a random character from your keyboard, type it in and say, this is a brand new operator. Reason being, again, the compiler needs to parse this code and check it. And it can only do that if it knows the operators ahead of time. And it's not something that can be updated on the fly. The compiler people work really hard to get this going. And it's not that flexible because of the amount of error checking that it does. And again, this all will like make more sense when you actually build a compiler in compiling class. So yeah, if you're still kind of like, but what if we do this and this? Well, hey, when you go ahead and do the Java, the not a compiler but assembler or whatever, just go ahead and do that and see how it goes. There are some operators. We're almost done here. There are some operators that cannot be overloaded. Okay, I have a link on these. I don't think these are all. Actually, no, they might. Yeah, I think these are actually all of them. Yeah. Basically, again, compiler for these, but also because why you'd want to do this. Like for example, size of is like internal to figure out how much memory a certain variable takes in memory. So in your specific computer. So overloading that just sounds like a really bad idea. Scope resolution operator is such a weird special thing that, like, again, I don't really see a purpose for overloading it or what you try to. The member access operator, I can see legitimately how you'd want to overload that to like create like the arrow operator per se, but they just were like, nope, this is just a big mess if you do that. So yeah. Also, you can't change current operator usages. So like, if you have two integers and you're using the plus symbol, that's always going to be addition. You can't overload that to now be subtraction for some reason or to like do something else. It's always going to remain. So you can't change the like current operators and how they work. You can only overload them to add functionality. Like we can make the plus work with special objects of class A like we did today, but we can't change how they work with integers. However, that doesn't mean you can't mix and match. So like I could have overloaded today, and if you remember, I can do that next time. I can overload my plus operator to be able to add an object A to an integer. So I could say like A1 plus 5. That I can do. That's fine because that's a new sort of operation that I'm doing that it would have otherwise wouldn't work. But again, what I can't do is just overload two integers because that one is built in. And then finally, operators can be overloaded either for objects of user defined type or that's not really a rule. That's just kind of telling you what happens. So yeah, these things are good. I think there's another thing I want to go over of this, but I'll look at that next time. But yeah, that's pretty much the basics of operator overloading. You pretty much know everything at this point. Now we're going to just show you the special cases and other things. Maybe do one with CN, one with file streams, one logical one. There's some fancy ones like the array index, which I don't typically cover. We can try that one next time maybe. We'll see if we have time. But it's mostly just kind of looking at documentation and using it. It's like when I show you this is a library and then you just go and kind of explore it. But, you know, it's not new. You're not learning something new now at this point. You're just sort of expanding on this. So, yeah. Well, hopefully this is useful. And again, operator overloading has great power comes with responsibility, kind of applies to that really. So with that, I leave you off to have a great day, and I'll see you guys on Wednesday to continue on this discussion. So I shall go ahead and post the next assignment, I suppose. So, yep. Take care, and I'll see you guys on Wednesday. Bye.